Hello students, in the last video I have explained to you how to take readings on a screw gauge. Today we will find out as to how to first detect whether the screw gauge has a zero error or no. The first thing that you should always keep in your mind is when you join the anvil to the spindle without the object being kept for measurement, if the zero of the circular scale exactly matches the main line, then there is no zero error. This is the figure which shows that this particular screw gauge does not have a zero error. In this case, you would see that the zero of the circular scale is lying below the zero of the main scale or the reference line, because of which this particular case there is a positive zero error. And when the zero of the circular scale lies above the reference line or zero of the main scale, then this is a negative zero error. When there is no zero error, then you do not need to apply any zero error correction. But when there is a positive zero error or a negative zero error, then you have to apply the respective positive zero error correction or negative zero error correction. Let us see how the corrections have to be applied. Keep in your mind that whatever the correction, either positive or negative, it has to be subtracted from the main reading. Errors have to be subtracted. So automatically a positive zero error will be subtracted from the final reading, whereas a negative zero error will be added to the final readings. Let us now find out as to how the corrections have to be applied. If you see the zero of the circular scale, is lying below the zero of the main scale or the reference line. Okay, so you count by how many zeros does this zero lie below. So this is 1, 2 and third division. So the zero of this particular instrument is lying 3 divisions below the reference line or zero of the main scale. So therefore, as it is, it's a positive zero error. 3 divisions below, so this is 3 I have taken here. Multiply it to the least count. The least count was found to be equal to 0.01 mm. So you take 3 multiplied by 0.01, you get 0.03 mm positive. So if the total reading is, for example, 6.65 mm, then your corrected reading will be equal to, remember I told you that any type of errors has to be subtracted from the final reading. Therefore this is a positive error, so total reading minus zero error will be equal to 6.65 minus 0.03, that's equal to 6.62 mm. Let us now take a look at the second case, which is namely the negative zero error. We have already seen that if the zero of the circular scale lies above the reference line or zero of the main scale, then it is said to be a negative zero error. In a similar manner, what we had done in the last case, count by how many divisions does the zero lie above the reference line. In this case, you see it is lying 1, 2 and 3 divisions above the reference line. So what we can do is, we'll have already counted the 3 division above the reference line. Similar manner, zero correction is equal to minus. Keep this in your mind, because this is a negative zero error. So you'll have to take that negative sign here. So if it is 3 divisions above, I have taken minus 3. If it was 6 division above, I have to take minus 6. If it is 7 divisions, you take minus 7. So if it is whatever may be the number of divisions by which it lies above, which is the negative zero error, you always take that number and minus. So minus 3 multiplied by 0.01, that's equal to minus 0.03 mm. And if the total reading, for example, is 6.65 mm, then the corrected reading will be total reading minus zero error. 6.65 minus of minus 0.03, that's equal to 6.65 plus 0.03, that's equal to 6.68 mm. Let us also take a look at the case, a second case when there is a negative 0 error. There we had counted by how many divisions the 0 lies above. Now you find out which division is exactly coinciding with the reference line. Here you see the number 47 is exactly coinciding with the reference line. Since the circular scale in this case has 50 divisions and the 47th division coincides with the reference line, so the procedure for this case would be error is equal to negative error anyways minus of, see there are 50 divisions in the circular scale, 50 minus that division which is exactly coinciding with the reference line multiplied by least count. Here in this case the 47th division is coinciding. If it was 44th division, then 50 minus 44. If it was say 43rd division, 50 minus 43, and so on and so forth. So minus 50 minus 47 into least count, that is minus 3 into least count, that's equal to minus 3 into 0.01, that's equal to minus 0.03. So in either of the two cases the error will remain the same, whether you count the number of divisions by which the 0 lies above, or you follow this method of finding out the coinciding division and then subtracting 50 and then taking the least count. The corrected reading part will not change anyways. Total reading minus 0 error, 6.65 plus 0.03 is equal to 6.68 mm. So this is how the 0 corrections are to be applied to the final reading.